going to be talking about the combined gas law. From its name and looking at the formula, you can tell that the combined gas law pretty much combines three different formulas so far. It combines Boyle's law, Charles' law, Gay-Lussac's law, and then there's another law that we didn't cover called Avogadro's law, and it puts them all together into the combined gas law. There's really no change. P is pressure, V is volume, N is moles, T is temperature. Don't forget about any pressure conversions like we did in the past. And any temperature in Celsius still must convert to Kelvin. How do you do that? You add 273. One thing to note is that if you ever see STP, conditions of STP, that is standard temperature, standard pressure, and that is 0 degrees Celsius, which we know is 273 Kelvin, and a pressure of 1 atmosphere. So anytime you see STP, that means 273 Kelvin, 1 atmosphere. That's what STP stands for. The nice thing about this gas law is if they don't mention variables in the problem, or if a variable stays the same, then you can just exclude them from the formula. So if they don't mention volume at all, you just exclude it from the formula. Okay, if we look at the first one, we have 150 milliliters of a gas. Milliliters is volume. Collected at 27 degrees Celsius. We know Celsius is temperature. You add 273 to that, and that's going to give us a temperature of 300 Kelvin. And 1.55 atmospheres, ATM is pressure. They're asking what would the final temperature be. So we're solving for temperature in Kelvin. If the volume goes to 125 milliliters, so there's volume, and the pressure goes to 1.7 ATM, there's pressure. So we have two volumes, two pressures, two temperatures, so we're doing the combined gas law. P1V1 over N1T1 equals P2V2 over N2T2. What does N stand for? N stands for moles. They don't mention moles in the problem, okay? So we'll just cross them out, so we'll get rid of the moles. And now the problem is a little bit shorter. So now we plug and chug. Our first pressure is 1.55 ATM. Our first volume given to us is 150 milliliters. Our first temperature, T1, we put into Kelvin is 300 K. Then we go to the right side. The second pressure went to 1.7 ATM, so our second pressure is 1.7. Notice our pressures are the same. That's good, no conversions. Our second volume went to 125 milliliters. And then finally, our second temperature, we don't know. That's what we're solving for in Kelvin. Okay, so now we have the problem set up. So now we're going to cross multiply. So some people call it the butterfly method. So you're going to multiply these, and then you're going to multiply these. What I like to do is find where is my variable, and wherever my variable is, I cover those up. So these go together. So the first thing I'm going to do is I'm going to multiply 300 times 1.7 times 1.25. So I'm going to go 300 times 1.7 times 125, and then I'm going to equal all that to 1.55 times 150 times t. That's what I get by cross multiplying. And when I do that, I get 63,750 equals 232.5 t. So I need to divide both sides by 232.5. Those cancel out, and that gives me a final answer. T equals 274, and temperature comes out to be in Kelvin. So there is one example of the combined gas law where we got to exclude a variable. If we take a look at the second problem, is a container is holding 4.35 liters. Well, we know that's volume of gas at STP. Here's STP. What did we say STP meant? STP means 273 Kelvin, 1 atmosphere. So the fact that they're telling us STP means we know we have 273 Kelvin and a pressure of 1 atmosphere, and it's holding 5 moles of a gas. Moles is in. What is the resulting new temperature? So we're solving for T. When 3.5 more moles are added. What does it mean to say more moles are added? That means they added them to how many we already had. We already had 5. We're going to add 3.5 more. So 3.5 plus the 5 we already have means our new number of moles is going to be 8.5. It says increasing the pressure to a final pressure of 5.25 atm and a new volume of 5.8 liters. So we have a bit of everything in this problem. This is a worst case scenario. So P1 V1 over N1 T1 equals P2 V2 over N2 T2. So what I'm going to go ahead and do is start plugging things in. My first pressure is coming from STP, which is 1 atm. My first volume was 4.35 liters. My first number of moles was 5 moles from the problem. And my first temperature was coming from STP, standard temperature, 0 degrees Celsius or 273 Kelvin. Now I equal that to the right-hand side. The second pressure went to 5.25 atm. Notice the first pressure was 1, and now it increased over 5 times. That makes me think the thing I'm solving for is probably going to increase as well. My volume was 4.35, and it says the final volume is 5.8 liters. My new number of moles, N2, it said we added 3.5 more. We added those to the original 5, so our new number of moles we said was 8.5 moles. And then we're solving for temperature T. So just like on the previous problem, we're going to cross multiply. So I find my variable, so all that's going to go together. So if I cover that up, first thing I want to do is multiply all this stuff together. And if you type all that in the calculator, that's going to give you 41,564.25. And now if I multiply all this stuff that I had here with my variable, that would give me an answer of 25.23 times my temperature. So I got these numbers by cross multiplying. I need to solve for T, so I'll divide both sides by 25.23. These cancel out. And my final temperature is 1647, and that would be in Kelvin. So 1,647 Kelvin. As you can see, our temperature started off at a standard temperature 273, so it increased probably about 6 or 7 times that amount. Okay, so let's move to the last problem. This last problem says a bag has 5.1 moles of oxygen with a volume of 2.4 liters. So here is moles, that's N. Here's 2.4 liters, that's volume. If 40 more grams of oxygen are added, what is the new volume? Let's assume temperature and pressure remains constant. So that means out of the combined gas law, P1 V1 over N1 T1 equals P2 V2 over N2 T2. We can ignore temperature and we can ignore pressure. So if I take out pressure and temperature, what I'm left with is nothing more than V1 over N1 equals V2 over N2. And this one is actually a special rule, a special law that is called Avogadro's law. Remember Avogadro's number? This is Avogadro's law. But we can get it from the combined gas law. We just cancel this stuff out. Okay, one thing we have not used is 40 more grams of oxygen are added. Where would grams fall into these? Which of these variables could grams turn into? Well, if you go back a couple months to February when we were doing stoichiometry and mole conversions, we know we can convert grams into moles. So I'm going to do that right quick. I'm going to take these 40 grams of oxygen. Oxygen is O2, and we can convert that into mole. Remember our technique of doing that? We multiply, draw your line. The word on top goes on the bottom, so that is grams of oxygen, grams of O2. And on top would be moles of O2. How many moles? 1. That's right, it's always 1 mole. So where did we get the grams from? That came from the periodic table. You might recall oxygen had a molar mass of 16. Excuse me. 16 times 2. (16 times 2 is 32 grams, so I'm going to put 32 down there. And now we can see that grams cancel out. And so basically we're going 40 times 1 is 40 divided by 32. and that comes out to be 1.25 moles. What happened to those moles? They were added. So they were added to our original amount. We originally had 5.1, so we're going to add that 1.25 to the original 5.1 moles, and we see 6.35 is the new number of moles. That's N2. All that to plug it into the formula. So now we can plug and chug. Our first volume was 2.4 liters. Our first number of moles was in the problem, 5.1. Our second volume, we don't know. That's what they're asking. What is the volume? That's V. And our second number of moles, we got the 40 grams. We converted grams into moles, and then we added that to the original number of moles. So that gave us a 6.35 moles, so that gets plugged in here. So now how would we solve? That's right, we're going to cross multiply. 2.4 times 6.35, when we times that, that's going to give us 15.24 equals 5.1 V because we cross multiply those. Now we need to solve for V, so divide both sides by 5.1. And volume gives us an answer of 3 liters. So our final volume is 3 liters. So there you have 3 different examples worked out of the combined gas law. Sometimes we're able to cancel out variables that we're not needing. Sometimes you're going to have to convert grams into moles or maybe moles into grams. And then don't forget temperatures. If they're not in Kelvin, add 273 to convert them into Kelvin.